Welcome to my virtual class. My name is Omeri Tobias. I'm here today to make a few notes and a video lesson on this channel of e-learning. It is Unit 2 Physics and it's about electricity. And today we are going to learn the following as we specify out in this Unit 2 of electricity what we have and what we need to do during and after this lesson. Unit 2 is about electricity. Now, we have learned over time that electricity is a form of energy that makes our lives better. Electricity provides energy for household appliances such as televisions and fridges. This unit will cover the following topics: mains electricity, current and voltage in circuits, electrical resistance, and electrical charge. In this topic, we are going to look at a number of things. At the end of this topic, you should be able to describe how electrocution and electric fires are prevented by electrical appliances. Describe the relationship between current flow, resistance, energy, and temperature. Describe the relationship between power, current, and voltage. Distinguish between alternating current (AC) and direct current. Describe the application of the relationship between energy transferred, current, voltage, and time. Now let's move on to this part here. This topic introduces learners to mains electricity. The main source of electricity to our homes is power stations. This one describes how mains electricity is supplied in homes and how electrocution and electric fires are prevented by electrical devices found in our homes. There is a power station here. There is homes, there is school, electricity box in the shop, and substation, and the cables, the poles carrying forward the electrical wires. Now, what happens here is that at the power station, there is electrical generation, and this is produced actually here. We have two wires, and I'm going to explain this in more detail. So the more important here is that at the power station, we are having two of these conductors, the wires, the aluminum mass, and one of these wires is earthed. Now, earthing means that this wire is discharging via some energy, and therefore this wire becomes now a neutral wire N, and the one that is not earthed is now called the live wire L. Neutral wire is the one that is earthed, and the live wire is not earthed, and that's why you've been able to see in this that the two wires here. This is what happens here. Now, the transmission. Electrical energy enters our homes through the underground cable. The underground cable connected to an electrical meter whose function is to measure the amount of energy used. Very, very important. Now, let's move on. Everyone of us can be able to associate with this kind of thing here. And let's move forward. From the electrical meter, the cable is connected to the fuse box or consumer meter, which contains fuse or circuit breakers. Circuit breakers and fuses are safety devices which shut off the electricity in a circuit if the current in them is excess. We'll be looking in detail how they really work. Wires from the fuse box are connected to the ring main circuit, which are installed in walls and floors. The rings main circuit. We're going to see here shortly how this rings main circuit is connected, just in a while. So how do we start it up with the ring's main circuit. There we go. Now these two wires, now the live wire has a fuse. We call this the company fuse, like that. Is about 60 amperes. 60 means it only allows a current below 60 amperes to flow through it. And then from there, just some demarcations like that. Then this one also have some demarcations. And remember, the earth wire is always installed at the host. Now let's say we want to make a 3-pin plug here. So we take live wire, we take the neutral, and we take the earth. So this we are calling the 3-pin plug. Live, neutral, earth. 3-pin plug. And that's how it exactly is. And this is how the connection is done. But alongside the live wire, there is a fuse. This is for, it's mainly for example, cooking and ironing and so forth. But on this live wire, there's another fuse that we can call the consumer fuse. So this fuse will be around 30 amperes. It's placed there. Now for lighting, we shall be able to see what happens in the lighting, but more in the syllabus. Be very patient to look at out what is happening here. Now let's continue. Electrical appliances are connected to the ring circuit via the plugs. There are 3 wires in the ring main circuit. Live wire, which is red or brown, depending on the country. For example, here in Kenya, we use both red and brown. In the UK, they use brown. In the United States, they use red. Neutral wire can be blue or black, and earth wire can be either green or yellow. There you go. The blue, which is neutral, the green, which is earth, and the brown, which is live. Now, the live wire transports electrical energy from the power station. The neutral wire completes the circuit. The earth wire conducts excess current when a fault develops so as to protect the user. You've seen those important functions. It is upon you to take a note. This is just other examples of circuits that continue to exist. Homes, we prefer actually the ring circuit because it takes less wires, let's say like that. So most of our homes are wired in ring mains circuit. Look at that. The main advantage of ring's main circuit is that less wires are used in wiring. Easy peasy. Now let's continue here. Homes are supplied with electricity within the range of 220 to 230 volts. This voltage of 240 volts is higher, and hence the casing of the plug is made of a plastic insulator to prevent electric shock. Let's look at the 3-pin plug. Look at the neutral wire, where is it? Now look at the live terminal. It has a fuse. The live terminal always have a what? A fuse. Then the earth wire. And you can be able to look at a close look at this. You'll be able to understand very importantly the 3-pin plug. The brass metal is used because it is a good conductor of electricity. What is the brass metal? This one here. This is the brass metal that we are referring to. This part here. Safety devices. Fuses. Contains a thin piece of wire made from a metal that has low melting point. When excess current flows in the circuit, the fuse melts and cuts the current, thereby preventing electrical wires and electric shock. This should be electrical fires. Electrical fires. This one here should be electrical fires. There we go. Preventing electrical fires and electric shock. The fuse must be replaced after fault for application to be functional again. That's very important. The fuse must always be replaced. So inside this fuse, you see there's a wire that can melt when there's excess current flowing through it. So each time there is this, that the excess current flows, you need to replace it. That is the commercial. Then this is the symbol of a fuse. Choosing a fuse. So now how do we choose a fuse? How do we choose a fuse? The choice of a fuse depends on the current description of the appliance. The fuse should be slightly above the current passing through the circuit. The fuse should be exactly. Now let's complete the table below by providing suggestion of a fuse to be used. For example, if the current in the circuit is 2 ampere, the type of a fuse should be slightly above. So that's 3A. If the current is 4 ampere, the fuse should be slightly above 4A. So that is 5A. Now, will you please tell me through the stream, just text, just go to stream, then answer, add a comment there. If it is 12A, what will be the type of the fuse? 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 Circuit breakers. Circuit breakers or trip switches are safety devices used in consumer units. When excess current flows through the circuit breaker breaks to prevent electrocution and electric fires. After the fault, the circuit breaker is simply reset. No replacement is required. No replacement is required. We have been able to explain this shortly here, and we should be able to see what happens here. Now here there is magnetization and demagnetization that takes place inside the circuit breaker. This is what it looks like. But in our next topic, we shall be looking at how it works. For now, just know that there are two devices that are used for safety. One is fuse, another one is the circuit breaker. The circuit breaker is more efficient than the fuse. Reason? Circuit breaker, you can reset it. Fuse, you must replace it. Very, very, very important. Hard wire connected to the metal case. Very, very important. The function of the hard wire is to provide protection when a fault develops in electrical appliance. Very, very important. In modern appliances, metal casing is replaced with an insulator such as plastic. Double insulation refers to covering the electrical paths of an appliance so that the user can touch. A two-flex wire is used in double insulation, and hence there is no need for each wire. Is it possible to note out these where there's a double insulation? I'm just going to give you. Now look at this. Look at this thing here. It is double insulated, so there's no need for earth wire. This is what we are calling double insulation. Double insulation, very, very, very important. Double insulation refers to covering of electrical paths through an appliance so that the user can touch. A two-flex wire is used in double insulation. Below we see that. So the switch is always connected to the live wire, as we saw earlier, to prevent the electrical shock when it is open. When the switch is connected to the neutral wire, what happens? The user may get electrical shock even if the switch is open. Very, very important. Heating effect of electric current. Heating effect of electric current. Now, look at this. The filament bulb and the halogen bulb. They have different resistance. The filament bulb has a higher resistance than the halogen bulb. Let us take note of this. Due to the conversion of electric energy into heat energy, the conductor becomes hot. This effect is called heating effect of current, otherwise called Joule's heating effect. Conductors with a high resistance causes higher heating effect than conductors with lower resistance. This should be done. Applications of heating effect of electric current include the following: hair dryers, electric cooker, washing machines, electric cookers, we repeated that, kettles and dishwashers. You know this, use them at home. They all apply the same principle. Assignment: list 5 more appliances that make use of heating effect of electric current. Let me see your work on your portal on the stream of the Google Classroom app. Electric power. Good. If an appliance is labeled 80 watts, what does it mean? It means that it is transferring 80 joules of electric energy every second. Every watt. Very, very important. Every second. 80 watts. Quiz. Above label 240, 100 watts. What does this mean? What does this mean? It means that this bulb is transferring 100 joules of energy every second. Every second. Every second. There's a relationship between power, voltage, and current. We are going to see that shortly. Then we wind up our lesson for today. What is the relationship between voltage, between power, voltage, and current? We can be able to say first that there's a relationship between voltage is equivalent to current times resistance. Very, very important. Therefore, we can be able to say that V is equal to IR. Sometimes you see this one being drawn like that, and you see something like that. There is I, R, and that means that V is equal to I times R, and R is V of I, and I is V of R. But we'll be able also to say that power is equivalent to voltage times current. Power is equal to voltage times current. Let's see an example here. Then we do it together. A 240 photocopier takes a current of 4 ampere. Determine the power of the photocopier. Let me work out that. So in that question 1, V is equal to 240. I is equal to 4, and therefore power will equal to VI, which is equal to 240 times 4. What do we get? We're going to get 0, 16.1. That is 8, 9 watts. So that will be my power. As easy as that. I'll give you one more question so that you can do that. Do this question. Calculate the correct fuse that should be used for 230 volt 1 kilowatt electric shower coil. Then do it in your book, then and take a photo of it, send it through your Google Classroom app. I'll get it. Thank you very much for this, for being part of Unit 2.1a. There will be part 2 of Unit 2.1. Let us meet in the next lesson. My name is Omeri Tobias.